Well, is this function differentiable? Check for continuity first, check for differentiability second. Quick check for continuity. If you plugged a -1 in here, we could do the whole limit thing, but let's just be real honest with ourselves. If we had to show work, we'd go through all that, and we will, but super quick check in our head. If this was multiple choice, I'd say -1 goes here, -1, that's -1, -1 goes here, square it's +1, now -1. We have continuity. It's the same from the left and the right. Let's make sure we understand that though from a different context, in a more articulate context. So we're going to do a continuity check. And let's abbreviate a little bit. Continuity, question mark. Do we have it? Well, g of -1 is equal to, it's -1. And the limit as x approaches -1 from the left of g is equal to, well, same thing, -1. And the limit as x approaches -1 from the right of g is also -1. So g is continuous at x equals -1. Okay, good. We have met the three conditions. We have the function that is defined, we have the limit that exists, and the limit equals a function. So we're good. All right. I didn't articulate that in this case where I didn't, and I didn't do it on the last one either. I didn't say this equals this equals this. I'm moving along rather quickly in this. Now we need to check for differentiability, so we are going to grab a marker that opens, and we're going to have the limit as x approaches -1 from the left, so we'll deal with stuff that is less than. So 2x plus 1 minus 2 times -1 plus 1, there's that, all over x minus -1, so x plus 1. Let's work through this. We'll figure out what the slope is. Can we save some trouble? We're going to figure out what the slope is. It's a line. We can identify slope when we have a line. I don't know why I'm waving my arms like this, but we can do it. If you were to continue to work through all this, you would eventually end up with 2. Trust me, you would. There it is. And it works, really. You'd have 2x plus 1 minus -1, so plus 1 again. You'd factor a 2 out. You'd have 2. X plus 1 cancels. It's fun. Second part, not so easy. Limit. X approaches -1 from the right. By the time we're done, if we have the same number on both of these, then we're going to have a function that is continuous and is differentiable at that point. So let's see, -x squared minus, and then -1 squared all over x minus -1, and that gives me, let's see, the limit as x approaches -1 from the right of -x squared, that is -1, so we have plus 1 here, and then x plus 1 here. Ooh, fun stuff. We're going to have some factoring to do. Do I have room? Barely. We'll bring it down here. I'm going to stand in the way so you can't see, because, you know, no, I'll move. The limit as x approaches -1 from the right, and let's factor that numerator all in one step. If I factored a -1 out, I'd have negative, and that would give me x squared minus 1, so that'd be x plus 1. X minus 1, and the denominator is going to be x plus 1. Cancel those out, and now we have something, excuse me, with no denominator other than an understood 1, and we can plug a -1 in. So we would have the limit as x approaches -1 from the right of negative, and then x minus 1 in parentheses. So question, can I plug a -1 in? Yes. If I plug a -1 in, what do I get? 2. Is this 2? Yes. Is this 2? Yes, because they're the same thing. The function is differentiable at x equals -1, which we showed. We demonstrated continuity, not as articulate as a full free response question, but we did articulate that by demonstrating a few things. And we also have differentiability because this limit equals this limit. So the function, let's see, how do I word it? Given the determinant, it does. So the function is differentiable at x equals -1. Now, if you want to get technical about it, the slope at -1, the derivative, the value of the derivative, is going to be, oh, have y'all seen this? Yeah, you have. You have seen, okay, I'm making sure you've seen that notation. I'm recording these videos out of order. G prime of -1 is equal to 2. There we go. That's it. We found it. Sorry, I had to stop and think, wait, have you seen this notation before? You have.